Chapter 14, Transformations. Today we're going to cover section 14.4, Rotations. Our objective for today will be to locate images of figures by rotation. And rotation, a transformation where the image is determined from rotating counterclockwise a given angle measure about a given center. And the notation, it's sort of a capital R, A comma 90 is the notation for a 90-degree rotation about center A. So the first thing I sort of noticed is the first letter that they tell me is where the actual center is. So if I get an example off to the side for this one, I could make the center be A. The second value, the number, tells me the actual angle measure that I have to rotate. And the number is always going to be going counterclockwise. So if I looked to the right, if I wanted to actually do this rotation, I would make A my center, and I would rotate, let's say I want to do for B over here, I would rotate 90 degrees, and I would have to travel that rotation counterclockwise. So if I imagine point B rotating 90 degrees counterclockwise, it's just going to rotate around, and since it was 5 units to the right of point A, it's going to end up being 5 units up above point A. So he would be actually my location of point B prime. Let's look at a couple other rotations. What if I did the rotation, I'll still pick A as the center, but let's say I went 180 degrees. Well, if I come back over to the side, A would still be my center. 180 degrees means I need to come this far, 180 degrees. Since B is 5 to the right, if I rotate it around, B would just be out here, sort of 5 to the left, and I'd be at -5 over here. Let's think about the following. What would happen if you had a negative rotation? So let's imagine that I had center still at A, but -90 degrees. So A is still my center, but now I'm going to go clockwise 90 degrees. And if I do that, B being 5 to the right is going to swing down here and end up being down here 5 units below. We could even get other sort of angle measures. Let's say I ended up doing, we'll still pick A as the center, -45. So I could do a 45-degree rotation. It would just get a little bit trickier to figure out where B is. I would have to end up doing either some sine, cosine, tangent, or I could start to use the Pythagorean theorem or our 45, 45, 90 shortcuts to figure out the actual ordered pair for where B is at. And the last one, what about rotations bigger than 360 degrees? Well, let's do this. So let's keep our center still at A. And instead of 360, let's make it larger than that. Let's say we went to 540 degrees. Well, how do you do 540 degrees? Well, every time you travel around 360, you make one complete circle. So I think of, well, if I have 540 and I get rid of 360, which is one complete circle, what's still going to be left from that? Well, we can go through and subtract. And I get 180. So the rotation of center A of 540 degrees is really the same as if I just went 180 degrees. So I can think if A was my center and I went 180 degrees, B is going to end up out here over at -5. Now, every one of these problems I've been doing A is the center, but A doesn't need to be the center. I could be giving you different problems where I have, say, a rotation where B is the center and I ask for 90 degrees. So if B is the center, 90 degrees is a counterclockwise rotation, which means it's going to rotate this way 90 degrees. Where would A end up? Well, A gets rotated that way, and it would end up being sort of 5 units below where B is. So when you get these problems, check two things really importantly. Where's the center, and then how much of a rotation are you going to do? A half turn is just a rotation of 180 degrees, which think about just like turn halfway through the circle. The notation for that, HA, is the notation for 180 degree rotation about center of A, and theorem 14.4, a rotation is an isometry. So if you have a congruent figure and you just rotate it, it's going to be congruent to itself. The diagonals of regular octagon ABCDEFGH meet at O and form 8 triangles. So I want to figure out the rotation about center O being negative 45, where does D end up? Well, the first thing I really should figure out is how big are all of these angles in here. So I know that it's an octagon. A complete circle is 360 degrees. If I divide that by 8, I get that each of these circles happen to be, or each of these angles are 45 degrees. So all of these angles inside here are 45 degrees. And now that's going to be quite helpful. So for number 1, O is my center. That's good. And if I start at D and rotate negative 45 degrees, so that's going to be clockwise, this way, 45 degrees, where would I end up? And I just end up at E. Number 2, what if I would do a rotation with O as my center? I start at H and I go 270 degrees. So 270 degrees, I'm going to go clockwise, 270 degrees. So the easiest thing for me to think is, every time I go over one letter, it's a jump of 45 degrees. So what's 270 divided by 45? And we can easily just grab our calculator, divide, and see how many letters we have to go around. So if I take 270, divide by 45, I get 6. So I'm really thinking it's just going to go 1, 2, 3, 4, 5, 6 letter around, I end up at B. Number 3, I do a half turn where O is my center, and I'm going from E. So the half turns are the nice ones, I think. If I do a half turn, I'm going from E, and I'm just going halfway around. And I should end up at A. Draw the image by the specified rotation. So over here I have to rotate about 90 degrees. So I'm thinking, for the most part, this whole shape here is going to rotate this way 90 degrees. So just in my mind, I'm sort of getting an idea of, I'm probably going to get a triangle that looks something like this over here. So now to figure out, how do I actually get to that spot? And to me, the easiest way to do it is go each vertex off of the triangle. So if I think of this one, I really look to get there, I'm going 2 right and 4 down. And if I rotate all of this 90 degrees this way, it's really going to get transformed into going up 2 and right 4. So as this rotates 90 degrees, I'm just changing my directions. So the direction to the right really ends up being the direction going up. The direction going down ends up being going to the right. So this new location, and let's label all of these A, B, C. So my A prime is going to be in that new location. And now I sort of work my way through the other points, thinking the same thing as I do all of them. So as I go through and start to look at, let's say, point C. Point C is 5 to the left and down 1. And if I rotate that this way, instead of going 5 left, I'm going to come 5 down and then right 1. And here's going to be the new location for C prime. And think of the same thing for point B. If I want to get to point B, that's really 5 to the left and coming down 6. And if I rotate all of this 90 degrees, instead of going left 5, I'm really coming down 5. And then I'm going to end up going 6 to the right. And my new point out here is B prime. So if I look at my new triangle form, I really just have the triangle C prime, B prime, up to A prime, which sort of does look like the same triangle that just got rotated going this way around 90 degrees. The one on the right, doing a half turn about center O. So I'm thinking everything goes 180 degrees. So if I look at all my points again, so I'll call it A, B, and C just like before. Okay. Instead of going right 2, down 4, everything is the exact opposite because I'm going halfway around the circle. I'm going to go left 2 and then up 4 and get that A is really, or I should say A prime is my point up here. So all the directions, the exact opposite for the half turn when the center is right at the origin. So let's look at C. So C is 5 left, down 1. Let's do the exact reverse, which would be 5 right, up 1. Let's look at B. B is 5 left, down 6. Do the exact opposite, which would be 5 right, up 6. And we'll connect and make our triangle. And then look, does it seem like we went through a half rotation? Or does it look like this triangle got rotated around 180 degrees? And it does. It got rotated. It's pointing the opposite direction. Instead of below, it's up above.